Okay, so this is a small distraction from this conceptual stuff that Kathy was, and more specific examples that Kathy was talking about. And the reason I want to kind of introduce this, because the concept of trust schemas have been for a while, and I think even in the previous tutorials we have introduced trust schema or version of the trust schemas, but that kind of wasn't as integrated as what the current work Kathy invented with the VerSec and DCT. So this is what we're trying to introduce, a little bit of a sneak peek of what the VerSec is and why is it kind of better for the purposes of this work. And before I kind of give Proyash a few things to talk about specifics, I just want to say a few, just tiny few words about the what is majorly different from in this trust schema compared to what we had before. So first of all, as you see, the language itself is more kind of, I guess, understandable for the human person to write, and Kathy will go over very specific examples, and you're probably gonna get a very good idea of what it is. But in reality, it's not just defining the trust schema per se, for kind of defining all the relationships, but rather defining statements about what application will be publishing and what application will be verifying from kind of top level. So here you see that on the central slide, on the central point, there's a statements about the publications, and these are essentially the key elements of this trust scheme or the output of this trust scheme. And the publications, effectively the items, the final leaves of this output of the VerSec trust schema can be constrained a lot of different constraints on the names with variables, and Proyash will show in a second. Plus, there is a structural relationship between names and relationship with them. With the names. So with that, Proyash, can you just continue?
Okay, so as Alex mentioned earlier in the previous slide, that we would like to have some publication templates, and also we'll have to show some like certification tags, like the relationships between name, like who can sign what. So here is an example of one of the VerSec goal, which is to define the publication templates. Um, so in the example, if we can see that a schema can have like multiple publication, and we can have a template for those. Like we can see if the publication of operator command need to follow these type of templates, like the LSNet ops, DNMP, target, command, p-type, prc, cid, and timestamp. And another publication, the user command, it can follow either one of these two templates. And VerSec will also provide a certificate DAG to demonstrate the signing relationships. For example, like a publication, it can be signed by a particular certificate or multiple certificates, which again can be signed by multiple certificates. And all of these should eventually reach to the trust anchor of the system, which is self-signed. Okay, so in this slide, we will see the language structure of VerSec a little bit. So we will start with the schema, and a schema will contain like multiple definitions. And a definition will also have three components. We will start with an identifier that identifies the definition, and it will followed by a colon sign, and finally there would be an expression. Again, an expression will have name or an identifier of any other definition in the trust schema, and the expression will also have like the component constraints and the signing constraints. However, these constraints are optional. So in an expression, we can see like either one of them or both or neither. And in the later slides, we will like explain more about these stuffs. So next slide, please. So we can think of a name, start with. So name, this is like pretty much typical the NDN names we have. It will consist a sequence of components which will be separated by the slashes. And here is an example of the name. And each component of the name, it can be a literal string that can have like actual value for the name component, and it can have like an internal function call that we can get in the runtime, and it can also be an identifier that I will explain more details in the next slide, and it can also contain like expressions. Okay, so identifiers are a very key concept of VerSec language, and they are mostly like variables. And in VerSec, we have like three different types of identifier. And the number one starts with an underscore. And what does it mean? It means this variable's value must be derived from anywhere in the schema rules. So if we see an example like network, it is mentioned as the foo bar. Okay, and if we have a command publication and command type of publication in somewhere that is defined as like a network, a topic, field, and function, so while we are compiling this, then this network, it would be replaced by the foobar stuff, and in the resulting, we can see the command has become like foobar, topic, field, and function. And we have another type of identifier, the hash identifier, which is basically used to describe the publication template like command, mypub, etc. And finally, we can have a regular identifier. And this type of identifier must be supplied at the runtime. So if we see in the example, the topic, this is a regular type of identifier, and it should be supplied at the runtime.
I just want to add a tiny thing. So for the example here is extremely simple, just stating there's a variable assigned to something and then there's substitution. But what happens in the actual VerSec is these statements don't have to be like one by another. There's basically the compilation stage is a deduction stage of what this variable should be, and all the substitutions happening like during the stage, not necessarily directly related. And another one that I don't think put here, maybe the next slide, is a relationship between different variables. But this one, I hope we're going to talk here.
Okay, so in this slide, we will discuss about the component constraint. So the syntax is pretty much simple. We would start with an open brace, then we can have one or more constraint terms, and then following by a closing brace. And we can have like multiple component constraints separated by or and sign. So if we see an example, like we have a mypub type of publication that is follows these type of parameters like the domain, topic, and param. So if we try to specify this with some component constraints and add this constraint like mypub, and the topic is request and the param is status, then this will generate at the time of compilation with this. So we have the domain fixed, then we see the topic should be replaced by the request and the param should be replaced by the status. And according to the same way, we can have the red one too, like the topic in this case will be replaced by the command and the param will be replaced by the start. And we can also have like a combination of this component constraint. Like in the first example, we can combine them using like the or sign, and we can get these two, like the topic will replace by the request and the status, and same way the command and start. And we can also add them by an and sign, and this will actually basically give the Cartesian products of all these terms. An expression can also have a signing constraint. So a signing constraint basically defines like who can sign what type of messages. And the syntax is simple. We will have a sign by operator, and it can be followed by one definition, one identifier, or multiple identifiers separated by the or operators. So if we look at the example, like this is a common type of publication, and at the end, we see that it implies like this common type of publication can be signed by the operator cert. This is a request type of publication, and this request type of publication can be signed by either an op cert or an user cert. Yeah, so I think that's all from my part. It's try to understand the language a little bit better. And now Kathy will provide an interesting example, like how to write an original trust schema.